Imagine your React application running smoother than ever, with lightning-fast load times and seamless user interactions. Sounds appealing, right? In today's tutorial, we're diving into a transformative approach to optimizing React apps by avoiding the overuse of JavaScript built-in methods. As a React developer, understanding how these methods can impact your application's performance is crucial. By the end of this video, you'll be equipped with insights and strategies to enhance the speed and efficiency of your React applications. We'll explore the nuances of built-in JavaScript methods like map, filter, and reduce, and how their overuse can lead to performance bottlenecks. You'll learn how these methods, although powerful, can become problematic when misused, especially in large-scale applications. We'll provide real-world examples and solutions to optimize your code effectively. Why should you care? In the competitive landscape of web development, application performance can make or break user experience. By optimizing your React applications, you'll not only improve performance, but also enhance maintainability and scalability. This is especially important for complex applications, where performance bottlenecks can lead to sluggish user interfaces and increased resource consumption. Our focus is on practical, actionable techniques that you can implement immediately. From understanding the impact of CPU-intensive operations to leveraging memoization for caching and reducing unnecessary re-renders, we'll guide you through the process step by step. These optimizations can lead to significant improvements in load times and memory usage, making your applications more responsive and user-friendly. If you're passionate about building high-quality, performant React applications, subscribing to our channel is a must. We consistently provide in-depth tutorials and the latest insights in React development, ensuring you're always ahead in the game. Hit that subscribe button and turn on notifications to stay updated with our newest content. Let's get started on elevating your React development skills today. In the realm of modern web development, React has become a cornerstone for building interactive and dynamic user interfaces. As developers, we often turn to the powerful tools within JavaScript's arsenal, particularly its built-in methods, to help manage and manipulate data efficiently. However, just like a chef who knows when to use a sharp knife and when to opt for a more delicate tool, we must be judicious in our use of these methods within React applications to avoid performance pitfalls. Imagine you're constructing a model city. Each building represents a component, and the roads are the connections between them. In React, the virtual DOM is akin to a scaled-down version of this city, allowing us to make changes without disrupting the entire structure. However, the tools we use to build and modify this city, our JavaScript built-in methods, can sometimes lead to unnecessary congestion if not used wisely. Take the map method, for example. It's like a postal service that delivers messages or data to every house or component in your city. While efficient for small neighborhoods, if your city grows into a sprawling metropolis with thousands of homes, using map indiscriminately can lead to traffic jams. Each time you call map, you're essentially sending out a fleet of delivery trucks, which can be computationally expensive as it reallocates resources to create new arrays and iterates over them. This can become a significant CPU load, akin to a citywide gridlock during rush hour. Similarly, methods like filter and reduce, while invaluable for data transformation and aggregation, can become resource-intensive when applied to large datasets within your React components. It's like using a massive crane to move small pebbles, effective but overkill, resulting in unnecessary energy expenditure and increased operational costs. To mitigate these performance issues, consider leveraging memoization, a technique akin to setting up a local depot for frequently accessed goods. By using hooks like useMemo, we can store results of expensive function calls, effectively caching them and avoiding redundant calculations. This is similar to a warehouse storing popular items, reducing the need for repeated trips to a distant supplier and thus optimizing delivery times. Moreover, employing strategies like server-side filtering can preemptively reduce the amount of data your application needs to process, akin to city planners' zoning areas, to minimize unnecessary traffic. By handling data transformation before it reaches the client, we can ensure that only relevant information is processed, leading to a smoother user experience. Another analogy can be drawn with the use of React.memo, which acts like a security checkpoint, ensuring that only genuine updates cause re-renders. This prevents unnecessary disturbances in your city, ensuring that only significant changes prompt a response. In essence, it curtails the frequency of re-renders by comparing previous and current props, akin to a watchtower monitoring for legitimate threats before raising an alarm. In summary, while JavaScript's built-in methods are powerful tools, their overuse in React applications can lead to performance bottlenecks. By adopting thoughtful strategies such as memoization, server-side data handling, and leveraging tools like React.memo, we can optimize our applications to be both efficient and maintainable. Just as a smart city leverages technology to enhance its infrastructure, a well-optimized React app uses these techniques to deliver a seamless experience to its users. As we continue to build and innovate, understanding and refining our use of these methods will be key to creating high-performance applications in an ever-evolving digital landscape. Let's dive into the core of our React application, the app.js file. This file serves as the entry point for rendering our React components. In this example, we'll see how to optimize our rendering logic by avoiding overused built-in methods. Specifically, we're employing the useMemo hook to cache expensive calculations and avoid unnecessary re-renders. Due to the length of the file, only the most relevant 30 lines will be shown. Now let's examine another vital part of our application, the product list.js file. This component handles the rendering of our product items. By using React.memo, we can prevent unnecessary re-renders of each product item component, thus optimizing performance. Here, we will show the essential lines of code that demonstrate this optimization. Finally, let's look at the configuration of our project in the package.json file. This configuration file contains the metadata about our project and the dependencies required to run it. Understanding this configuration will help you set up the environment correctly. The most critical lines will be shared here. To observe the practical application of optimizing React apps by avoiding the overuse of JavaScript built-in methods, we will walk through a demonstration of an optimized React application. Initially, the application loads with a user interface where a prompt is displayed, asking the user a question with a Yes button available for interaction. Upon clicking the Yes button, the application processes the input, and this initiates a transition in the interface. This part of the demonstration highlights the efficiency of handling user input without unnecessary re-renders, showcasing the importance of optimization. Following this, the application simulates user activity by scrolling through the entire page content. This action demonstrates how the application maintains performance while dynamically updating the user interface. The smooth scrolling experience is a testament to how avoiding overuse of built-in methods can positively impact performance. Subsequently, the user interacts with various UI elements by clicking on items labeled laptop and tablet. Each interaction is met with a responsive update in the interface, showcasing how optimized React components can manage state and props efficiently. This ensures that the application remains responsive and quick, even with multiple interactions. Finally, the demonstration concludes with the application scrolling back to the top of the page. This action further illustrates the effective handling of user navigation without incurring excessive performance costs. Throughout the demonstration, the application maintains its performance benchmarks, underscoring the effectiveness of the strategies implemented to avoid the overuse of JavaScript built-in methods. In our journey to optimize React applications, we've delved into the intricacies of avoiding overused JavaScript built-in methods. By understanding the impact of these methods on performance, we can make more informed decisions in our code to enhance efficiency. These strategies not only boost the speed of your applications, but also improve memory usage and responsiveness, directly benefiting user experience. As you implement these techniques, you'll find that React's performance capabilities extend far beyond initial expectations. Your applications will run smoother, load faster, and provide users with a seamless experience. Now, take a moment to explore these concepts further in your projects. Experiment with memoization, strategic use of React hooks, and optimize data handling to unlock the full potential of your React apps. By subscribing to our channel, you'll gain access to a wealth of knowledge that can transform your development process. With practical examples and insights, you'll be equipped with the tools to tackle real-world challenges effectively. Join us as we continue to explore and innovate in the world of React development, accelerating your learning journey with each video.